This is the Ultraprobe 2000 ultrasonic leak detector. This multifaceted instrument provides testing capability ranging from simplistic forms of leak detection to extremely sophisticated methods of mechanical analysis. The technology of ultrasound is concerned with sound waves that occur above human perception. Since ultrasound is a high frequency, it is a short wave signal. Its properties are different from audible or low frequency sounds. A low frequency sound requires less acoustic energy to travel the same distance as a high frequency sound. Let's examine the basic components of the kit and their functions. The main component of the Ultraprobe is this metered pistol housing. In the back of this unit you have a meter. This ballistic meter has intensity increments from 0 to 100. The 50 divisions reflect intensity changes only. The more intense the ultrasonic signal, the higher the reading. This red light will come on only when the batteries need recharging. The increments on this dial allow for 500 individual set points. There are 3 sets of numbers. The outer window reflects the whole digit and reads from 0 to 10. The inside digits are for fine-tuning, and these increments are smaller increments, shown as lines which represent 2 divisions each. As the numbers go up in value, the sensitivity of the instrument also goes up. The maximum sensitivity level is 10. The minimum sensitivity level is 0. On the sensitivity selection switch is a lock lever. This allows a user to lock the sensitivity selection and thereby prevents it from being moved inadvertently. To lock the sensitivity selection, rotate the lever clockwise. To release the lock, rotate the lever counterclockwise. This jack is used to plug in the headsets and tape recorder when one is being utilized. The Ultraprobe is always off until the trigger switch is pressed. To operate, simply press the trigger. To turn the instrument off, release the trigger. On this dial there are numbers ranging from 100 kilohertz down to 20 kilohertz. These represent the range of frequency selection capable with the Ultraprobe. These frequencies may be tuned in when performing mechanical analysis with a contact probe, which we will show and explain later. There is also a detented position, labeled fixed band. This selection automatically locks the circuitry of the Ultraprobe into the peak response of the transducers of either the contact module or the trisonic scanning module. This position is most often utilized. It is extremely useful in ambient noise situations, since it allows the Ultraprobe a narrow frequency response. Most conflicting ultrasound noises will be minimized. There are 3 positions for this meter mode dial: linear, log, and auxiliary. The linear position can be considered a slow response. It eliminates the high and low swings of the meter and averages the response for a more measurable result. This selection is utilized when monitoring bearings or in mechanical analysis when too rapid a meter response might be confusing to the operator. The log position allows the meter to respond in a real-time instant mode. This selection is used when fast instant meter response is needed, as in leak detection. The auxiliary position is to be used only when a specially adapted instrument is to be interfaced with the Ultraprobe, such as a chart recorder. This jack is where the recharger is plugged in. There are 2 wires from the recharger. Either plug will fit, the Ultraprobe jack or the tone generator jack. When the battery low level light goes on, immediately recharge the Ultraprobe for 8 hours only. Now let's examine the use and function of the 2 attachment modules, the trisonic scanning module and the contact module. This trisonic scanning module is utilized to receive airborne ultrasound, such as the ultrasounds emitted by pressure leaks and vacuum leaks. To use the scanning module, align the prongs with the 3 corresponding holes in the front end of the metered pistol housing and plug in. Select the log position on the meter selection dial. Position the frequency selection dial to the fixed band mode. Start with the sensitivity selection dial at maximum. Press the trigger and begin to scan the test site. This rubber focusing probe is used to block out stray ultrasound and to assist in narrowing the field of reception of the trisonic scanning module. Just slip it over the front of the appropriate module. This contact module with a metal rod is utilized as a waveguide. It is sensitive to internally generated ultrasound, such as within a pipe or bearing housing or actuator. The probe extension kit consists of 3 metal rods that will enable you to reach up to 31 additional inches with the contact probe. For general use, position the frequency selection dial to fixed band, then touch your test area. Start at maximum sensitivity on the sensitivity selection dial. Proceed to reduce the sensitivity until a satisfactory sound and meter level is achieved. The tone generator is an ultrasonic transmitter designed to flood an area with ultrasound. When placed inside an empty container, such as an aircraft cabin, it will flood that area with an intense ultrasound that will not penetrate any solid but will flow through an existing fault or void. Turn the tone generator on by selecting either low for low amplitude signal or high for high amplitude. This flickering red lamp indicates the tone generator is on. A smooth, continuous, warbly sound should be heard. If a beeping is heard instead, then a full recharge of the tone generator is needed. For more information, refer to the instruction manual. What produces ultrasound in a leak? When a gas passes through a restricted orifice under pressure, it is going from a pressurized laminar flow to low-pressure turbulent flow, shown here. The turbulence generates a broad spectrum of sound called white noise. There are ultrasonic components in this white noise. Since the ultrasound will be loudest by the leak site, the detection of these signals is usually quite simple. The same is true for vacuum leaks. The only difference between the two is that a vacuum leak will usually generate less ultrasonic amplitude than a pressure leak of the same flow rate. The reason for this is that the turbulence produced by a vacuum leak is occurring within the vacuum chamber, while the turbulence of a pressure leak is generated in the atmosphere.
Here we will demonstrate the Ultraprobe procedures for the following aircraft systems: tire air retention, pneumatic ducts, cabin pressurization, oxygen systems, internal bypassing. Tire air retention can be checked by utilizing the trisonic scanning module on the Ultraprobe in the log mode and the fixed band position on the frequency selection dial. Scan the entire bead of the tire and wheel assembly. Scan the thermal fuse plug and air valve for air leaks. Pneumatic ducts can be checked in the same manner as tire air retention without removing the cargo wall paneling. Just scan along the fiberglass panels to locate the airborne leak. Cabin pressurization can be checked by utilizing the tone generator with the Ultraprobe. Place the tone generator inside the aircraft at a designated door or window. Pressurize and maintain that pressure. Outside the aircraft, scan the entire door or window. You will hear the warble tone generator. Using the headset and reading the meter, identify significant leaks. Oxygen systems are checked by the same method and settings as with the previous systems. Just scan the supply lines, valves, and the diluter demand regulators. Listen for a rushing sound while observing the meter. Follow the sound to the loudest point. Internal bypassing can be detected by utilizing the contact module in the Ultraprobe. Select the LIN mode on the meter selection dial. Position the frequency selection dial to fixed band, then touch your test site. Internal bypassing in valves can easily be monitored to determine if a valve is operating properly. As the use of this versatile ultrasonic instrument expands, so will the applications.